Hello everybody and welcome to this video for example 6 and topic 3, lesson 5. We're going to look at solving polynomial inequalities by graphing it, and then you guys are going to do a try it. And I love graphs. But the first thing I'm going to do is I'm going to get a clean page here and I'm going to post it here. The first thing I'm going to do is I'm going to kind of do this algebraically a little bit, just so you guys can see that way instead of just jumping straight into the graph. What I'm going to do is I'm going to treat it like this is x cubed minus 16x equals 0. And I know it's less than 0. I know the problem says less than 0. I need to make a mental note that it's less than 0. But for the solution part, I'm going to make it equal to 0. Because what I want to do is I want to find where in my graph, I don't need such a long line, where I cross that x-axis. All right, so first steps first, always do this, is look for your greatest common factors before you go into factoring. All right, so here I could pull out an x. And I have x squared minus 16. And there's the difference of squares. Identity, and remember the difference of squares identity is a squared minus b squared equals a plus b times a minus b. So it breaks up into the factors a plus b and a minus b. Looking at this, 16 is a perfect square and x squared is a perfect square, and we're taking the difference of them. So I'm going to break this up. I'm going to use that identity to break this up. So I get x minus 4, or I guess let me do plus since I start plus here, and x minus 4. Okay, zero product property. I'm going to set each of these to 0. We got x is equal to 0. X is equal to negative 4 for the second factor, and x is equal to 4 for this third factor. Okay, looking at my line, move it down a little bit more. Looking at my line, here at 0, we have, that's really thick marker. Here at 0, we have a crossing either from positive to negative. Here at negative 4, and here at 4. These are the only doorways we have to go from positive or negative and negative to positive. So again, we could go to the graph. We could look at what the graph looks like. Again, I'm doing this algebraically because the book will go to the graph and we could use the book for that part of the example. But for those who like to see this algebraically, let's look at this algebraically. So I'm going to see what happens when x is less than negative 4. So I'm going to choose negative 5. I'm going to substitute it into this equation here. So we get negative 4 times I said negative 5, and then what I do, I go and put negative 4 in there. Abney, we got to really pay attention to what I am saying. I myself need to pay attention to what I'm saying. I think it's something like that. So negative 5, then negative 5 plus 4, and then negative 5 minus 4. And again, we're just looking for the signs. We're looking at the factored sign. So this factor sign is a negative. This will produce a negative 1, which is going to be a negative, and this would produce a negative 9, which is negative. So we're looking at negative times negative, which will give me a negative. So we're down here in negatives. Then 4 to 0. I'm going to pick negative 1. And so that's a negative 1 times negative 1 plus 4 times negative 1 minus 4. Expand my page. So we're looking at negative times positive times negative. So this is going to be positive here. Now between 0 and 4, I'm just going to choose 1. So we have 1 times 1 plus 4 times 1 minus 4. So this is going to be positive times negative, which is going to be negative. That one negative makes the whole thing negative. And then again, we don't have any multiplicity, so I could assume that we go back up into the positives, but I'm just going to write it out. 4 less than x. X is equal to 5, so we have 5 times 5 plus 4 times 5 minus 4. My sign here is positive. My sign in this factor is positive, and my sign in this factor is positive. So we're looking at positives. Okay, so the thing here is they want us to find the solutions where this was less than 0. And so we have less than 0 here at -4 between for x is less than -4 and 0 less than x less than 4. And we don't include these values because those values are 0, and 0 is not positive or negative, and this is also not equal to 0. All right, so there we have it. I don't know what happened there. There we have it algebraically. Let's look at in graphically. So the solutions for this defines a polynomial. So again, they said do this by graphing, and then they do it algebraically. They find that they have -4, 0, and 4. They sketch the function of the zeros. So that's kind of what we did when we did this number line, but instead of actually sketching it out, which I could, we just determined where they're positive or negative. So the blue portions are greater than 0. The red portions are less than 0. So the solutions are x is less than -4 or 0 less than x less than 4. All right, so you have to do that twice. Notice the operands. You can, again, set this equal to 0 to find your zeros and then determine where it's greater than 0 or less than 0. My preference is you do have access to the graphing calculator. They do want you to graph this. So I would just look at the graph and get those skills on what's positive, what's negative down. So go make sure that there is no additional questions. And there you have it. So we do have one more. Since we are at the last example here, we could do an enrichment example. That's something else that you have there. It is not going to be required, but it's a nice thing for you to go into the math book and look at, considering these polynomials and exactly what they do. Dive a little bit deeper into your understanding. And then we have the concept summary about multiplicities. We have it about the functions, a, b, and c, what the graphs look like, how to interpret the graph, what the graph is actually saying, the end behaviors, leading, coefficients, and degrees. So I hope to see you in the next video, and have a wonderful day.